speak that the presentation is flashing. I don't know what that's all about, but we'll figure it out. So this is one of my first times using Hopin as a presenter. I'm going to do my best as the tech specialist that I am. I want to show you some things. As a matter of fact, if you don't mind, I want to start this off with one of my absolute favorite things. So I'm going to stop sharing here. And I'm going to share this. Yes, a dance party. It's always time for a dance party. Dancing is one of my absolute favorite things. If you are familiar with code.org's Hour of Code dance party, please let me know in the chat. Also, let me know if you can hear the sound that's being played in the video.
Hi, my name is Miral Kadbi, and I'm a dancer, software developer, and creator of Illuminate. Computer science relates to creativity in numerous ways, immeasurable, really. I mean, once you have the ability to write software, you can put ideas into anything. I do it with light suits. There's so much you can do once you have the tools to write software, and the possibilities are really endless. Over the next hour, you're going to get started with computer science by programming your own dance party. We've assembled some hit music and a team of great dancers for you to play with. You'll be using blocks of code to choose different dancers. Change your dance moves, make them respond to the music, and make them interactive. You'll see that your screen is split into three main parts. On the left is a play space. This is where your dancers will show up. The middle area is the toolbox. New blocks of code will be available in this space as you go through the lessons. The space to the right is the workspace. You can drag blocks out of the toolbox and into the workspace to build your program. The instructions for each level will be up here at the top of the screen. If you need a hint, just click the light bulb. To start off, let's make a new dancer with this red block. First, drag it out of the toolbox and snap it under this orange setup block. This dancer's a cat. You can also change where the dancer appears in your play space with this. Above the play space is the menu for picking out music. There are a ton of songs to choose from, so have fun finding your favorites. Under the play space is the run button. When you press run, you'll see the dancers from your program appear in the play space and the music will play. Try it yourself. And if you're feeling stuck, it's okay. Just get up and get moving. And before you know it, you'll have made your own dance party. So, what will you create?
So we are going to talk about, good morning, and welcome. My name is Julianne. I'm going to introduce myself in a few minutes, and I'm going to give us the agenda. So welcome. If you are joining me synchronously, or if you are joining me asynchronously, I thank you so much for coming out to the CS for NY Summit 2023. Yay! I am talking to my elementary educators right now. I have some tips and tricks for you. I hope that you have some things to share with me during this time as well. A poll just went out. So if you're live with me right now, you can jump on the poll right now. Oh, that sounded kind of funny. You can take the poll. Right now, we are taking a look at Hour of Code, but we're going to go past an Hour of Code. But this is one of my favorite activities. So there's always a video to get you started, let you know what's happening if you have not used this already. And then there might be a series of videos throughout to give some explanation. Sometimes you need to talk to your tech department to make sure that you can view these videos. I think things have all worked out now where most districts are able to view those videos. So Yes, they want a little feedback. They want a little research. They want a little data. I'm over 21, so I'm just going to click that. Sometimes I even just tell my kids, click on any number. I know that's not correct for the research, but if I'm having conversations with them about data privacy, we talk about that. So yes, I have all my information of what it is that I'm going to do. And I saw that some of you said that you've done this before and that you love it. And if you want to just jump on here with me now, you can just Google code.org dance party. Before we get a little deeper dive into what we're going to do this morning, I just want to do a step or two, if you don't mind. And dancing in your chair is an option, or you can also get up as well. So I need to make my cat dance. I'm going to stick with the cat, not the sloth. Just going to drag my block. Everything that the computer needs to do needs to have a command, right? So the command, after we put the code together, this command is run. I have a song already set for me, but as you can see, there are tons of songs that students can choose from. Once I hit run, oh, I was just about to get into it. Give me a sec. I'm going to check my chat and see how everyone is doing. Yes, Rebecca, thank you so much. I really appreciate that for putting the link right in there. Okay, so I can either replay, right? Maybe adding a different song. Let's just go anywhere and click run.
Can't nobody tell me nothing. You can't tell me nothing.
Or I can continue. Again, like I said, there is a series of videos throughout Dance Party that will give you some more information. Try that again. More information about what's coming up next. So now we're talking about events. I'm actually going to click off the video. So my directions are, I want to get the cat to clap when I press the up arrow. So now I can either press the up arrow on my keyboard, or once I start coding, I can even, or once I hit run, I can actually press the keys right here with my mouse. So let's see, I already have my setup. I need to bring out and snap together. And now I can hit run. Perfect. And again, just hit continue. And we can keep going on and on and on and on. And what I love is at the end, when you finish, you can print out your certificate. Kids love the certificates. I love plastering them all in the classroom, or right now I'm not in a classroom, so I'll plaster them out in the hallway or by my office. Lots of fun. So if you have not participated in that, please get in there and dance. Have a great time. Just play around. Any questions or comments before we move on? And if I take a look at the poll, let's see. Looks like we have a lot of instructional specialists here today. Okay, great. Welcome. One administrator, welcome. Welcome, welcome, welcome. Okay, so let me go back to my chat. And I'm going to share my screen. We're going to go over to our presentation. And I want to pause for just 1 second so I can get my presenter notes. It's a little behind the scenes information happening right now. There we go. I have my presenter notes up and ready. Going to minimize my screen so I can see my chat and see if there are any questions happening. So again, hello, my name is Julianne Ross Kleiman. I work at a really cool agency where our main goal through our North Star commitments is to help everyone develop their unique self. And through that, we also work on building capacity for our community. What I specifically do is I'm a district data coordinator, data privacy officer, and tech specialist. I help to manage technology in our own school-based programs. I train, I'm part of our DEI committee, and where I work is Ulster BOCES. And so we were just plugged using Dance Party from Hour of Code. But have you seen Program to Dance by MIT? Let me know in the chat, yes or no. Years ago, when MIT first came out with Scratch, they put together a curriculum guide. No. Okay, cool. Excellent. Success. The curriculum guide is free. What I love about Scratch, what I love about Scratch Junior, is that all of their resources are free. Now, Scratch Junior, which I am going to show you, is free. You can use on an iPad, you can use on a Chromebook. You do not have to worry about New York State PII or EdLaw 2D because it is an app that you download. It is not collecting anything. Scratch. Scratch, MIT. We're trying to get you to sign off on our paperwork, but no worries. You can actually download Scratch onto your computers, so then we don't have to worry about working in the community. But yes, that is so much part of it, because learning from one another is what makes everything just amazing. So Program to Dance is a series of videos where the goal is, and there's a lesson that comes along with this. That's why I say it's plugged and it's plugged because somebody has to show the video. It's unplugged because you will have someone standing in front of the video with their back towards it so they cannot see it. You will have someone in front of the video. The person is going to watch the video, and then they are going to program the dancer by giving a set of steps, hopefully so that when the programmer says run, the programmed person will be able to follow the steps identically to the dance behind them. Now, the audience that is watching, they're not allowed to speak. They're not allowed to give suggestions, and the programmer is not allowed to physically move. They just have to give an algorithm a set of directions. Hey, Jim. So what you do to make this unplugged, in my idea, is I noticed that when students were doing this, they would get so excited, but I wanted them to be focused as well. So the unplugged piece is, why can't they sit there and write a set of directions, algorithm for how the dance should be? So that it was, so we can have different iterations. Does that make sense what I just said? Let me know. Yes, no, maybe so. Yes, okay, cool. Yep. So Program to Dance, there is a link for it. I can make sure that you have all of the links available from my session. I'm also wondering if you can even just click on them. I don't know when you come back, but I'm going to have a little handout for everyone. So I'll make sure that all those tools are there. It is so funny. I've done this with third graders and I participated in it. So you can do this at any level that you feel comfortable, the way in which you feel comfortable. So this makes it a plug and unplugged kind of activity, especially if you make sure that your audience members are writing down an algorithm. So I already introduced myself. We are ready to go. What I'd like to talk about in the time that we are together is my essential question. How can we go beyond an hour of code to create and support a safe and positive learning culture in our classes through plugged and unplugged coding activities that align with the New York State Computer Science and Digital Fluency Learning Standards? Whew, that was a mouthful. So my goal is everything that is highlighted in blue, I'm going to define for you, and I'm going to give you some activities. I also want to share with you And I'll put this in the chat as well. And paste and send. I was so excited to see that, sorry, just trying to get my window back. I was so excited to see that Manhattanville College is sponsoring this event. I am a Manhattanville College student, and I am actually currently doing research on the New York State Computer Science and Digital Fluency Learning Standards. If you are interested in speaking with me, it's about a 20-minute conversation. This would be part of my research, and I can give you more information. Please click on the link to make an appointment, and we can discuss further. I'm specifically looking for K-6 teachers or ed tech leaders, technology specialists, who work with K-6 educators. So while we're working together today in the time that we have, can we agree to ask questions, be curious, and just continue to create? If you agree to that, can you either give me a thumbs up, a happy face, a yes, a maybe? If there's something else that you want to add to this, please let me know. I'll take a thumbs up. Thank you. I'll take that. Thank you. I'm sorry, could you tell I was an elementary educator in my life? So what we're going to do in the time that we have together, and I keep looking to the right to make sure I'm checking my time, is I'm going to define terms. I'm going to let you discover the apps, lessons, activities that I created for elementary students specifically. And then I thought we'd have a little debrief. And I want to get from you as well what you're doing and what works well. So if you even want to come on and talk or put it in the chat, let me know. So let's start with some definitions. I always think it's important that we're always on the same page in regards to definitions. So first thing I want to talk about is Computer Science Education Week. And that was launched in 2009 during the week of December 6th. The intent of that was to celebrate each year during Grace Hopper's birthday. I'll tell you who she is in a moment. Do you know who Grace Murray Hopper is? Tell me in the chat if you do. Code.org came right behind that in 2013. And Hour of Code and Code.org also are celebrated during that time. The goal for both organizations who are funded and are supported by so many other wonderful organizations is to make sure that schools help to increase the participation of coding for all students. So it is an hour, so it's just an introduction. But we want to go past that hour. So here's a little fun fact. Do you know who Rear Admiral Grace Murray Hopper was? She was a scientist, a mathematician. I love her. Excellent. She was a scientist, a mathematician, a computer scientist. She was the first person who came up with a compiler, a program that can translate other code into other code. And because of her, we have that phrase bug. If you take a look at the picture on the right, yeah, she actually pulled a bug, a moth, out from behind a UNIVAC computer, and you can see how big those computers are. Yes, that is what she is standing in front of in the picture on the left, a computer. This was from 1947. And so when we say debugging, we're talking about fixing an error in a program. Well, that was her error. She had to pull out the moth. She coined the phrase bug. We now say debugging. Just a little fun fact. So let's go back to our definitions. When I'm talking about plugged, I'm talking about coding and teaching concepts that are using electronic devices, right? Your iPad, your laptop, your phone. And when I'm talking about unplugged, I'm talking about coding concepts, learning those skills, because skills is most important, that are not using electronic devices. So we might still be using technology like a pencil or paper, but we're not using electric devices or electronic devices. And then I think we all know, but let's just take a look. We know that on December 14th, 2020, the New York State Board of Regents adopted the first ever K through 12 New York State Computer Science and Digital Fluency Learning Standards. And the standards are a response to a directive by the New York State Board of Regents that all New York State learners will develop technological literacy to enter college, to become productive members of the workforce, and to succeed as citizens. This comes from New York State Ed Department, quoting something from one of their articles or one of their news briefs from 2020. These standards will ensure that every student knows how to live productively and safely in a technology-dominated world, including understanding the essential features of digital technologies, why and how they work, and how to communicate and create using technologies. Just curious if you want to share, where are you on the timeline? If you want to put that in the chat. I know many schools are just, I'm going to go back for a second. I know many schools are just at the awareness building stage, and that's great. And that's why you're here, I hope. So that's all right. Wherever you are, start from where you are. And then we know that there are different standards. And we know that technology is a large part of children's lives, and the ability to understand and use technology safely and effectively to learn, communicate, and create is critical for 21st century life, work, and civic engagement. Again, this comes from the Board of Regents 2020. So our standards, impacts of computing, computational thinking, network and system design, cybersecurity, digital literacy. There are strands or grade bands, K through 1, 2 through 3, 4 through 6. So I'm going to focus specifically on computational thinking, going from K to 6. So what is code? I love Brain Pop. Who is using Brain Pop? Love it. Let me know in the chat. Awareness. That's okay. Excellent. Yes, love Brain Pop. So I took a little quote from them too about what is code, because we keep saying code, 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 code. Computer program is a series of steps a computer can follow, and programmers write these steps. And the language that the computer is using to process is known as coding. And the lines of instruction are known as code. Love sharing Brain Pop Junior with students in elementary in regards to introducing them to computer science. I think they do a wonderful job. I mean, who doesn't love Moby? I'm sorry. And just like all of the different languages that we speak, and I might ask my students in the class, what different languages do you speak? How enriching is it that you're able to speak more than one language? Well, computers have different languages as well. Here are some of the different languages that computers use to code or to understand code. Some of those languages are blockly based, as we know, where you're dragging pictures and snapping them together, and others are written text. How many of you are familiar with Seymour Papert? I have a little note I want to just go grab to make sure I give you the information that I want to give you about Seymour Papert. So he's often referred to as the father of logo. He worked closely with Jean Piaget and colleagues at MIT Media Lab. The goal was to create something that would help students to support the building of knowledge in one's head And they felt that to build something in the real world was going to help with understanding coding. So, having computer programs, a robot, a drawing, a story, or a musical composition. Doesn't that sound like Scratch? Right, MIT Media Lab. This feeds off of the original logo. So as you can see on the right-hand side, we have logo and it's text-based, and it will get logo's the turtle, and it will get the turtle to move. But then the understanding that let's connect the virtual world with the real world and have an actual turtle to program so that we can, or students can create pictures, kind of remind you of maybe Bebots or Ozobot or something that if you might have used before. So here's where it started. So this is not new. Here's where it started. And then we have many researchers, educators who have built upon that to make it more accessible to students. Now, according to Tinker, yes, the program Tinker, there are 10 reasons that students should learn to code. What do you think those 10 reasons are? Put them in the chat. I'll give you a moment. What do you think might be a reason that students should learn to code? Social skills. Yes, problem solving. Analytical thinking. And are these skills just isolated to coding? I don't think so. All right, so if you want to put some more things in the chat, you're going to let me know if you can hear this video. If not, I'll go out to YouTube and grab it. So let's see if we can hear this. And see if one of the things that you said is right here. Oops. Let's see if I do it this way. I'm going to find it. Or maybe I'm not going to find it. Okay, give me 1 sec. I can make this happen. This is where I'm supposed to be playing that technical difficulty music, I think. Please stand by. All right, so let's come back here. Let's stop my share and let's see if I can go to YouTube itself, put in the URL. Ah, it's not working. Of course it's not. All right, I can make this happen. I am debugging the problem as we speak. If you give me 1 sec. Aha, there's that video. Let me go get that link. Let me come back to you all. Oh, did someone put it in the chat for me? You are like so fantastic. Thank you, Chris. Okay, well, thank you so much. YouTube and commercials, love it. Yes, I definitely saw some of the things that you said were right in that video. Thank you, Brian Aspinall, for putting that video together and saying, sure, Julie, you can share that with everyone. So in the last part of this session, let's talk about some of the lessons and things that I have done. Let's see if I can get back to my slideshow. I think this is it. Yeah, perfect. Let's put her in slideshow mode. Let me view you all and hop in. Excellent. So now I lost where I was. I can't move to the next slide. Let's see. I can make this happen. Okay. If you all give me 1 second, I'm just going to shut everything down and bring it all back up again. And I thank you for your patience. Oops. First, let's go. Let's go grab our slideshow. Let's put it in present mode. Let's go back to where we are, where we were. Perfect. Okay. And let's make sure that that screen is shared with you. Yes. Okay. You can see me, you can hear me. We're all back in the same place. I hope. So, let's go back. So computational thinking. When we're talking about computational thinking, and this is one of the standards, we are talking about 4 main concepts: decomposing, abstracting, pattern recognition, and algorithms. Specifically for the time that we're together, I'm going to talk about pattern recognition. Patterns, I think, are one of the most fun ways to introduce coding and the concepts of computational thinking to elementary students. You know why? Because we're already doing it. We are already doing it. And for the other pieces, decomposing, right? We're just taking something large and pulling it down into smaller bite-sized chunks. We do that already. Abstraction. What piece really is not fitting in here that we're going to pull apart? And algorithms, as I said before, we're just writing a list of instructions so that someone can follow, kind of like a recipe. So again, specifically for this, we're going to look at pattern definition. So let's discover some of the things that I have done with students. As I said before, one of my favorite lessons when I have the opportunity to come into a classroom to work with someone in regards to coding, and I've done this in kindergarten all the way up to 6th grade and even beyond, is tell students that we're going to watch a video. We're going to discuss what it means, what computer science means, what coding means, and we're going to do that through a video. I love showing either Brain Pop or Brain Pop Junior. Most people do have it. It is subscription based. And if you don't have it, I'm going to show you a freebie in 1 second. The reason I specifically love Brain Pop Junior computer programming video is because if you take a look at the picture in the background, this mimics Scratch Junior, because that's what we're going to also use in my lesson. So I come in and I explain that we're going to watch a video. I'm going to code you or program you, and then you are going to program the computer. If you do not have a subscription to Brain Pop, there is a video out there called What is Code on YouTube from BBC Learning. Very similar to the Brain Pop, very cute, and goes through the steps of what is code, what is computer science. So this is a freebie that you can acquire on YouTube. So after watching the video and discussing it, what I like to do next is say, I'm going to program the students. And what I use are the Scratch Junior blocks. And I put up the blocks on the screen. I ask them to come join me, and I ask them to even see if they can tell me what they think these pictures mean. So that very first picture, someone wants to put in the chat, what does this block mean? What is this block asking us to do, that very first picture? And how many times is it asking us to move left, Lynette? Thank you. What do you think? Excellent. What do you think the second block, or the block in the middle, is saying? What do you think? Now, yeah, I need you to know, a lot of kids usually say jump up. They really do. And that makes sense. That's not incorrect. But for this language, it means something different. So when a student can process all the different ways of what that block can be, I make sure that they know that that is really good critical thinking. But for this language specific, it means this, and it does mean move forward. So if you all wanted to even just stand up and move around and do these things to get up out of your seat, that would be great. I'm going to program you in just a minute. And what do you think the last one means? What's that last one? Yeah, see, you might think that too. Yep. In this language, it's not a repeater because there actually are command blocks for repeaters. So this is a basic move. So this one means it wants you to turn to the left once. Then I let students know that before the computer can do an action, there's some kind of command. You know, is there a go, a run, a start button? In this program specifically, there's a green flag. What does it typically mean when there's a green flag? Like if we were in a race and there was a green flag, what does that typically mean? That's right. We're going to go. Exactly. And then you would assume that we want to stop. There actually is a red stop sign in this program. So this is Scratch Junior. How many of you familiar with Scratch Junior? How many of you use this? Put it in the chat. So what I do now is I tell students that I'm going to program them. I have them come up to the front of the room, and we all get together, and I have them physically walk through these moves. So before we had go to the right or move to the right. Now we have, move to the left. Now we have move to the right once. Can you put different numbers in there? Sure. And we'll practice that. So if you just want to get up and stretch, you're welcome to do that. The next one is now. What do you think this might be? Anybody, what do you think this one might be? No? Well, this one, if you're so inclined, get on up and you will hop 2 times. Forward and return. Oh, that's great. I love that thinking. In this language, it's actually hop 2 times. And then the last one, what do you think the last one might be? What do you think that last one? Stop and turn around? That's a good answer. I like that answer. Repeat. In this language, it means something else. So let's think of pirate treasure. X marks the spot. That's kind of my clue for you. Do the no, Jim, it's not do the hokey pokey. What it means is X marks the spot. I want you to go back home where you started. Ah, so if you were to put a sprite, that's what they're called. Um, if you were to put a sprite on the screen and the sprite was coded to do different motions, and when the program reset itself, I wanted it to go back home, I'm going to use this key. So yes, this is from Scratch Junior. So here was that lesson again. We watched a video. I then programmed my students using the different code blocks from Scratch Junior. All of these resources are free on the Scratch Junior site. And then I asked the students, okay, now you looked at these different blocks. Could you use these blocks to actually code something in Scratch Junior? So I am going to go get the video link for this so that I can show you what I did. The one thing about Scratch Junior is you can only watch it on Scratch Junior. So I'll show you what I did so that I could share it with you. So if you have an iPad, because this is on Scratch Junior's free on an iPad, what I did is I did a video recording of my screen. And so now you can see I created an all about me. I'm showing you the different blocks that I used. On the right-hand side, you can see that there were 4 stages. This comes from Tufts University in collaboration with MIT. They've decided that they just want to stick with 4 stages. I think you can hear it. That's my face in there, by the way. So what are all the different tools that students, or even different skills that students are learning when using Scratch Junior? Can you just flood them in the chat for me? What are all the different skills, all the different tools, all the different ways in which students are learning when they're using Scratch Junior? Or if you even want to tell me what curricular areas did I touch upon when doing this, creating this all about me? And I'll go back a little and show you some of the code. I have my green flag, my up arrow, my move to the right. I actually introduced my voice. I was able to record. I hope you were all able to hear it. There's my go back home. So that's why I want the students to kind of play Simon Says with the code blocks first on the screen, so that when they come into the program, it looks familiar to them and they can intuitively create a presentation. So again, oh, and when we get to the end here, I'm stopping, but I'm going to the next stage. So I'm going to stop my share, hopefully get back to my slideshow. But in the chat, can you tell me, what skills did we just learn? What skills did students just acquire for using Scratch Junior? Let me make sure I can see you all again.
I'm Shashi. I'm a video editor and content creator.
Lost everything. Let's try that again. Add the link to the video. Is that what you're asking? Yes. Yes, I can do that. Let me get back to sharing my screen again. And let me make sure I can get us back to the right place. Oh, oops. I will definitely share that with you. I just want to be, actually, I'll tell you where I'm going to share it. I'm going to give you a resource. Go back again. I'm going to give you a resource. I messed up my presenter mode. And so now I'm trying to move everything around on my screen. I'm going to share a resource with you, and I'll put all those links in there. Yeah, testing and debugging. You're definitely looking at literacy. You're looking at math if you're saying how many steps, because you have to figure out how many steps it really took to get across that screen and stop. There's so many things that students are doing. You're going through iteration. It's all about me. I'm being creative and making it personal because I'm able to take a picture of my face and put it into one of the characters. So many skills that are happening. So in the remainder of our time together, and my gosh, it's going by so quickly, I just want to show you some other activities. And like I said, I want to leave you with resources. So I will make sure I put that link on that page for you. Actually, hold on one second. Here we go. And I thank you for your patience, as this is my first time working with Hopin by myself. Here you go. Here's that link, but I'll also put it in the other space. So here we go. So if you're familiar with reading the standards, what this says is, because there are different sub-concepts in each of the standards. So this is one of the sub-concepts for computational thinking. We are in the K through 1 strand of computational thinking. This is standard 1. To identify and describe one or more patterns found in nature or designed, and examine the patterns to find similarities and make predictions. So what I love to do plugged, if you do not have Go Noodle, you can definitely jump on Go Noodle. Go Noodle has a really funny song called Banana, Banana, Meatball. And there's a lot of motion that follows along with the words. And so the whole song starts off by saying, make a pattern, make a pattern, make a pattern every day. And so they, in the video, make different patterns with different words. This is plugged because you're watching it. If you don't have this, could you do head, shoulders, knees, and toes? Does anybody remember that? Am I dating myself? Could you do bingo, B-I-N-G-O, and have the conversation of the pattern? What's going to come next? Could kids make up their own dance steps? Absolutely. Math manipulatives. So to go along with that standard, we're always using different Unifix cubes, Cuisenaire blocks, tangrams. Before you use them for math, and creating patterns is a math concept, but if you're doing addition, subtraction, play. Let the kids create and play by creating patterns. Maybe you're making a pattern and you're asking them, what do they think is going to come next? Or they're making a pattern for you to decipher what is going to come next, or for their peers. Aren't these things we're already doing? Aren't you already doing this? Absolutely. Do you have any other suggestions that might go along with this standard? If you do, could you please put them in the chat? That would be wonderful. So if we move on to the next strand, grade strand, we're looking again, we're looking again at modeling and simulation. This is for grade strand 2 through 3. I'm like tongue-tied this morning. Computational thinking, standard 1. Now we're going to create a model of an object or a computational thinking process in order to identify patterns and essential elements of the object or the process. You're going to say, oh, she's using a lot of that Scratch and Scratch Junior. Yes, I am. Love it. Why? It's free. And they have so many resources that you can use. There's a curriculum guide that has plugged and unplugged activities that you can span throughout the whole year that include music, art, literacy, math, social studies, and here's science. There's a video called Austin's Butterfly. What's really cool about Austin's Butterfly is has anybody seen that video before? It takes students through the process of iteration by watching how, when a student received feedback on his butterfly, he was able to change it from one thing to the most amazing thing through feedback. Well, why not create a butterfly garden in Scratch? There is a way in which you can color your own patterns. And then once you've made your butterfly, colored your butterfly, you can now program them in a garden. Butterflies in nature, great way to talk about patterns and other animal prints. And now here we are, we're plugged activity doing this within Scratch. Or we can go back to those blocks again. Create an algorithm coding with blocks. Did you ever have someone sit in front of you and then you put up like a screen so they can't see what you're doing? And you're giving them directions to make what you have on your side of the screen. You're giving them step-by-step instructions to make or mimic what you have. Can they follow your pattern? When you take down the screen, will they have the same thing? Have you done that before? You probably have. Well, this is a great way to talk about plugged and unplugged coding with students using blocks. And then the last one that we're going to look at, modeling and simulation for grades 4 through 6, computational thinking, standard 1. Now we're going to develop. See how those words are changing? You're going to develop a computational model of a system that shows changes in output when there are changes in input. Sounds like physics to me. Again, yeah, I did go back to Scratch. Why not the water cycle? When there are different changes. And again, you can make this interactive, just like the dance party was interactive in the beginning. Maybe if I press the up arrow, rain will happen. If I press the down arrow, maybe the sun will come out. So as you're making your presentation interactive, things are affected by different inputs. The way in which we interact with the computer will show you different outputs in the code. And the James Dyson Foundation challenge cards, absolutely love these. Let me actually see if I can go to this for us. Stop share for a second. Here we go, challenge cards. Are you ready for a challenge? You can download the challenge cards for free. There's always a video that goes along with it, some explanations, but even just thinking about the balloon race car, right? Different inputs, different outputs. Which one of these balloons is going to go further? Why? We're looking at patterns and having that conversation. So it's not so much about the code, it's what you all said earlier. It's the skills, it's the problem solving that all go into the critical thinking, that all go into coding. And these are the skills that we want to teach our students. So now let's see if Julie can get back to her presentation. And please, if you have any questions as we're coming down to the end, please put them in the chat. I hope some of this was helpful. All right. And here, I want you to just discover a few more. So I did create a, what do we call these again? On the right-hand side. Oh, boy. Choice board. Thank you. I put together a choice board of other things that I think are wonderful. I love the idea of using extensions, peripherals, different things that connect to programs. So robots on their own, fantastic. But when you can connect a robot to a program like Scratch or like Snap and make it do something, you're working in the virtual world and you're working in the physical world. I think that's amazing. There are also some robots that stand alone, and there are some programs that stand alone, like Microbit. If you ever had Osmo, there are some coding programs in Osmo, absolutely adorable. But they also extend up to older grade students as well. So on this page that I'm giving you access to, I will add more things at the bottom. So if you go to the page today, that's great. Go back in a day or two, and you'll see that there will be more resources. All the links that were in my slideshow, I might even just put the slideshow in here so that you can access everything. So as we're wrapping up and we're debriefing, did you ever do an FQR? Fact, question, response. As we end our time together today, I would love if you can share with me maybe a fact that you learned, or a question that you still have, or a response in the chat. A response could be, oh, didn't know that. Ooh, that's interesting. Wow, I'm going to try that. So as we wrap up, I would love if you either give me a fact, a question you might have, or a response. And while you're doing that, fact, question, response, there is actually one more thing that I want to share with you. The link on that page is also going to take you to a Padlet. So on the Padlet, I'm going to add additional K through 6 beyond an hour of code. Got to fix that. It's a beyond an hour of code. Let's fix that, beyond an hour of code. So I'm going to add additional things in here, and I hope that you will come in and just click on the plus button and add something that you like as well. That's all I have because our time is running out. Is there anything that you would like to share or say, or let me grab that Padlet for you. Love the Brain Pop Unplugged activities you shared. Wonderful. Yes, I've taught kindergarten, first grade. I've stayed in elementary education as an out-of-classroom teacher for literacy and technology. So these are all things that I have tried with students. And as a tech specialist in model schools and even in my role now, everything that I'm sharing with you is something that I've tried. And for our students who learn differently, these are sometimes absolutely wonderful activities in middle school and even high school. So that is my morning. Go on the website. There are so many amazing resources on the website. I hope that you explore. Again, whether if you were here with me synchronously or asynchronously, I am so happy that you came out to share your time with us at CS for NY 2023. Thank you, everyone.